Now let's talk about some properties of the derivative. So I'm going to assume R and U, these are differentiable vector valued functions. W is a differentiable real valued function. So it's just a regular function. And C is going to be a scalar. And so we have the following properties that hold. So the first one, and a lot of these properties are very similar to properties that you had before with functions. So if you take the derivative of a constant times a function, a vector valued function, it's a constant times the derivative of R. If I take a sum or a difference and I take the derivative plus or minus u of t, this splits up into the derivative of R plus or minus the derivative of u. And then if I have the derivative of a function of real valued function times a vector valued function, it's kind of similar to essentially the product rule, w of t times r prime of t plus w prime r w prime times r. If I take the derivative of a dot product, the derivative of r dotted with u, you're going to get something similar to a product rule, but for a dot product. So it'll be r dot u prime plus r prime dotted with u. We also have the cross product. Number 5, the derivative of r cross u. And it's kind of a product rule there too. It's r cross u prime plus r prime crossed with u. Rule number, or property number 6 says if you take the derivative, it's kind of an analogous version of a chain rule of r of wt. It would be r prime of wt times w prime and then property number 7, our final property, says if r dot r is c, where c is a scalar, then r dot r prime is 0. So let's look at an example here where we compute some of these things. Let's find, so for r of t, it's going to be 1 over ti minus j plus ln tk. And the function u is going to be t squared I minus 2tj plus k. Find each derivative. So the first one is going to be find the derivative of r dotted with u of t. So you could compute this dot product and then take a derivative, or we can use our properties here, use our previous properties. So I think it's property number 4, which tells us that this is r dotted with u prime plus, so maybe I'll write this on the next line so we don't run out of room here. This is r dotted with u prime plus r prime dotted with u. So r is the vector 1 over t, negative 1 ln t. We're taking the dot product with the derivative of u, which is 2t, negative 2 and 0, plus r prime. So the derivative of 1 over t, it's negative 1 over t squared, 0, 1 over t, dotted with the vector u, which was t squared, negative 2t, and 1. So we're going to compute these dot products. We get 2 plus 2 plus 0. And then if you compute the dot product over here, you're going to get negative 1, 0, and 1 over t. So in the end, I'm getting 3 plus 1 over t. And remember, because you're computing a dot product, you shouldn't have a vector anymore in your answer. Let's compute one more of these. So b, let's compute the derivative of u crossed with u double prime. Okay, so we're going to use our property number 5 here to compute this. This is the same thing as u crossed with u double prime plus u prime crossed with u prime So here I'm looking at I, j, k, and the vector u was t squared minus 2t and 1. So we need the second derivative, so it would be 2, 0, and 0. Remember, we had a property that said if you take a cross product of a vector with itself, this is just 0. It's just the 0 vector. So I just need to compute this one cross product here. Minus 2, 1, 0, 0, I minus t squared 1, 2, 0, j plus t squared minus 2t, 2, 0, k. So then I'm getting 0i minus negative 2 minus a negative 2j plus a 4tk. So in the end, I'm getting 2j plus 4tk.